Okay, so today we're talking about the numbers behind photosynthesis and so we looked at these two processes and kind of what goes on in them. So now I just want to cover the numbers side of what's going on to kind of get to our CO2 plus H2O. How does that get to the C6H12's O6 plus O2? How do we get there? And what I think I wrote down the initial equation, 6 CO2 plus 6 H2O. 6 CO2 plus 6 H2O leads to 1 CO2 and 6 O2. Is that what I wrote down? Making sure. Yep, 6 O2. Awesome. Cool. So we have our light-dependent reactions, and those are going to make... See, I'm looking for it on my notes here. Oh, light-dependent reactions. No carbon dioxide yet. The light-dependent reactions are going to take 2 H2O, 2 NADPH, plus, and 3 ADP, plus 3 inorganic phosphates, and with that, they're going to make 1 O2 molecule, actually 3 O2 molecules, right, because we have, oh no, just 1, can't do math, plus 2 NADPH, and then 3 ATPs, okay, but in our original equation we had 12 H2O, and this is why. So when we get this to 12, if we divide that by 2, that was going to become 1, 1, 1/3, or we could divide it by 2, or just multiply by 6, because 12 equals 2 times 6, and we already have our 2, so if we multiply by 6, this is going to become 12, this is going to become 12, 3 times 6 is 18, this is 1 times 6 is 6 O2, 2 times 6 is 12, and then 3 becomes 18. It becomes 18 too. So from the light-dependent reactions, we get 6 O2. This is going to come out as waste in our reaction, so that's accounted for. And then we have 12 NADPH, and then 18 ATP. Cool. So now I want to talk about the light-independent reactions. Okay? And so I had a lot on this, but in general, what we're doing is we're taking in, for each cycle, we take in 3 CO2, and it's going to take 9 ATP and 6 NADPHs. NADPH. And so if we look at the Calvin cycle here, in here would come 3 carbon dioxides, and this would be 6 ATP, this would be 6 NADPH, and this would be 3 ATP. Right there. So 6 and plus 3 is 9 ATP, plus 6 NADPH, plus 3 carbon dioxides. And I'll cover that more in a little bit tomorrow. So then, all this gets turned into one. This really gets us one G3P molecule, or one P-gal molecule. And we need to do this twice, because we do the Calvin cycle twice, to multiply everything by 2, to get 6 CO2 plus 18 ATP plus 6 NADPHs to get 1 C6H12O6, or 1 glucose. So now we're going to take out what we got. So we put in 12 waters, H2O, that's going to be coming from our light-dependent reactions. We put in, we have, 6 times 2 is 12, but we get to we make 12 NADPH here, we use 12 NADPH here, so it cancels. We make 18 ATP here, and we use 18 ATP here. And then we put in 6 CO2, so we're going to need 6 CO2. And then we got energy from the sun. I'm going to put that in little parentheses, because that isn't a substance we can measure. And that gets us our 1 C6H12O6, our 1 glucose. And then we have, remember, our 6 oxygen as waste. So that comes down here too, and we get 6O2. So that's kind of how we get this equation of photosynthesis. And we kind of just take the numbers and the coefficients out of it, so we basically have CO2 plus H2O gets us, plus energy. Energy gets us a glucose and then oxygen. So kind of when we think of photosynthesis, and we think of this reaction, it's really this reaction, and there's a lot more to it. And so that's kind of a little bit of the numbers in photosynthesis, and I hope that was helpful.